I know.
You need to break it, the big I said.
With the phone.
Sure.
They don't call them kids.
Huh?
This kid's a new.
Well, like, it was also all the different ways. It was kind of
All right, let's focus. On the shark bite, what questions do we want to see you go over? Have questions for me? 2, 3. Any others? All right, for number 2, we are solving this equation for B. So we have to get rid of the 2a. You can make that negative 2a or make it negative b, doesn't matter. If I get rid of 2a, I'm going to multiply it on the other side. We have 2ax equals negative b. Then to get b by itself, divide both sides by -1. We have negative 2ax equals b. Questions there? Okay. Then for number 3, are the following pairs direct, inverse, or neither? Let's take a guess first. Do we think they're direct or inverse? Okay, so if they're inverse, we could multiply these. If we get the same number, that would be inverse. So 6 times 4 would give us what? 4, 2 times 12, 4, 24 times 1, and 3 times b. So that was the same. This is inverse. Other questions on the trick, right? I do not. For a long while. Shouldn't be very long. If you don't get them this week, definitely right when we come back.
No, oh, you said to go one paragraph for the line from the you taking.
All right, take out your notes from last class, put phones away. You should have those in that. If you were not here, it should be on your desk already. Those notes look like this. If you need another one, I do have extra.
Can I get one?
I may have to print off more. That's not so nice. All right, you're ready. Right, bones away.
And walk with it.
Okay, we did the front and back of this, go onto this page. Here,
Oh, wow.
here. All right, on this, we're just gonna summarize everything we kind of talked about before. All on the same page, so we have everything, so everyone that wasn't here, if this doesn't make sense, ask me questions. But this would be everything that we talked about last time. Okay. So things that are vertical deal with y values. Things that are horizontal deal with x values. And we're gonna draw different graphs to show what is happening. I'm actually gonna make this small. So I'm gonna draw a graph that's moved up and moved down. We talked about the parent function starts at the origin. It usually faces up. And if it has a plus, that would be a shift up. Or you could use the word translate. And you put which direction it went and by how much. Yes. So there are graphs that we graph that you'll have to go back and find those notes. Anytime we move it up or down, that's a vertical shift, or you can say a vertical translate. And you would put, did it move up or down by how much? We're going to talk more about these. These are just the specific general overview. This, that was just me putting slash. This,
I will push it. I'll put that. That's easy. Or
vertical shift. Okay. Horizontal shifts move left and right. I'm gonna just put this on two separate ones. Yes. You're right. You're right. I drew that wrong. Here. That's why I meant to draw two. Okay. So that can shift up or it can shift down. It starts at the origin and it either shifts up or shifts down. Thank you for catching that. Horizontal can be shifted to the right or to the left. When we talk about the format, these will be things that happen on the inside. Vertical things are things that happen on the outside. If it's translated, it's really doing one of these things. So it can move up, down, left, right. So we're not going to redo that part, but reflected. If this is the original, reflected would be at the same place, but upside down. This would be a vertical reflection. Or a reflection over the x-axis. And then there are horizontal reflections, which we'll deal with very infrequently, but if I have my parent function that starts at the origin, horizontal reflections just do this. So it doesn't really look like it changed. It looks like it flipped over top of it. I'm gonna attempt to draw this, but I'm not an artist. But it's moving around the y-axis. So that would be a reflection over the y-axis, and then we'll stop there. Go back to the seat. What?
Just become my word. Louis probably like.
It's so good. Oh, yeah, the passion there.
Yeah. So, but it's on my list of things.
You should go. It's so good.
Probably not today though.
You might catch one of it.
Me and Mohammed, they don't work together. Okay, for sure.
Sorry.
And Mohammed's like,
All right. Mohammed, phone
he
away.
doesn't work that hard.
Amanda, phone away.
He doesn't let that go work.
Melanie, we are phone away.
What do you think?
Okay. For stretch and compress, we're gonna draw two graphs for both. One is gonna be for the vertical and the other is gonna be for the horizontal. So we talked together last class about vertical stretches and compressions, but not about horizontal. We won't be dealing a whole lot with horizontals. You just need to know what they look like. So vertical stretch, whatever the function is stretching towards the y-axis, so it's getting narrow. So if it starts at the origin, it's like really tall and skinny, narrow. And then some things about it, this would be a vertical stretch where it gets narrow and it stretches towards the y-axis, if you want to write that. Stretch toward y-axis is what that says. Horizontal stretches do the same thing, but they stretch toward the x-axis. So it's horizontally stretching, so it's going to look wider. So the vertical is stretching up or down, depending on where it is. Stretching towards the y-axis. The horizontal is stretching towards the x-axis, and it's wide. And then the vertical compressions do the opposite of what they're doing here. So vertical compressions are stretching away from the y-axis, so it gets wider because of that. it's stretching out from the y-axis. So it is wide, but you can say it's like shrinking or compressing away from the y-axis. And then horizontal, instead of stretching towards the x-axis, it shrinks or compresses away from the x-axis, so it actually gets narrow. It depends on the function, which we haven't talked about that. But these are just visuals so that when we do talk about, okay, when we're given different translations, transformations, we can say, okay, this is a vertical thing, this is a horizontal thing, this is gonna do this is gonna do this, and it's gonna look like this. The main thing we need to focus on is the differences between the vertical and horizontal stretches, compressions, reflections, translations or shifts. And then I'm gonna write here, yeah, sure. I'll write this up at the top. These are two different types of functions, so I'll write both. When we write our transformations, they're going to be in one of two different formats. Either f of x equals a times the absolute value of x minus h, outside of that plus k. Excuse me, where h and k would be your vertex. H is your horizontal shifts. K is your vertical shifts. A is any vertical stretches or compressions. If we had a number inside here, don't put this, but if you had something in here with this in parentheses, that would be where your horizontal verticals and compressions. Say it again. What is the K? That's your vertical shifts. And then you might also see one similar, but instead of absolute value, your quadratics. So A pretend that's an A for all general purposes. Parentheses x minus h outside of that squared, outside of that plus k. Please follow it. Melanie, follow it. A is going to tell you your reflections, your vertical reflections. It's also going to tell you your vertical stretches, compressions. And then we talk about the shifts. So we have to keep those in mind as we're talking about these practice problems. If you need to write them further down, we can do that. So let's look at number one. If f of x equals x squared, so that's telling you what the parent function is translated 4 units down and 2 units to the right. We have to write the equation that matches that. So they're going to always tell you what that parent function is. That's going to be our base. What would it look like? And then we have to look at whatever else is given. It's translated. Remember that it's shifts. 4 units down and 2 units to the right. So you have to decide what's horizontal, what's vertical, where's that going to go, what is that going to look like? So if it's going down, would that be vertical or horizontal? Vertical. And then to the right, would that be horizontal or vertical? Because these are both shifts, a vertical shift is your K value. A horizontal shift is your small h value. So we're gonna have something on the inside and something on the outside, adding or subtracting. All of your functions are gonna start however it's given, f of x or y equals the function plus u. If we only have these two, we shouldn't be adding in extra things. So does it say anything about it being reflected, stretched, compressed? No, so that means the A value is gonna be 1. You can put the 1, you can leave it off, it doesn't matter, your A value is 1 if nothing changes. Then we have H value. Remember that when we were doing the graphs, when it moved to the right, it was actually negative. The X values, the inside things, they do the opposite. So it's gonna be X minus 2. And if we were to graph that, we would see it move to the right. Squared, outside. Whatever your vertical is, that is just what it is. So if it says 4 units down, how would I write that? Minus 4. And what's nice is you have your calculator, so you could graph this and double check it. Does this go, or does it move down? Did it move 2 units to the right? So I'll put this in just so we're all on the same page. You can put in the one, you don't need the one. If I go into my graph, I'm also going to put in the original just so we can have something to compare. If this was my original, I see that it moved to the right 2 and down 4. It looks like it got wider, but that's just because it's at a different place. It didn't actually. It's the same. Questions on that before we do another? Okay. Number 2, f of x equals x squared is reflected over the x-axis and translated 7 units to the left. So we have our parent function is reflected. It's telling you we're going to reflect over the x-axis. Over the x-axis would be vertical or horizontal. Vertical. And then translate it, so it's going to move, shift 7 units to the left. Would that be horizontal or vertical? Horizontal. So the reflection tells us that's a negative. That is our A value is going to be -1. If there was also a stretch or compression, we would put that there as well, but there's not. The reflection tells us there's a negative. And then we have a horizontal shift. It's to the left. It's going to be the opposite of what you think. How would we write that? X plus 7 inside squared outside. Question so far? Okay, number 3. This was wrong. It should say stretch. And the next one should say compress. So now we have if f of x equals the absolute value of x is stretched vertically by a scale of 4 and reflected over the y-axis. So what's nice about being stretched or compressed, it tells you whether that's vertical or horizontal. You don't have to guess. If it's reflected over the y-axis, is that a horizontal or vertical reflection? Horizontal. This would be vertical, but this would be horizontal. So then if it's stretched vertically, that's something that's gonna be on the outside, that's gonna be your A value. And then we're gonna have a negative in there somewhere, but because it's horizontal, that's gonna be on the inside. All of your horizontal things go on the inside. So we have f of x equals our A value, which they tell us is 4. Then we're dealing with absolute value, not quadratics anymore, so we need our absolute value bars. And then how would I show this reflected over the y-axis? What were you about to say? There is an x, yes, that x would have to be there regardless. But how do I show that it's been reflected? The negative. To put a negative right in front of that x. Questions on that one? Notice that there's not a square for this because it's not a quadratic, it's an absolute value. Do not get those confused. Don't start adding in squares for these. Don't start putting absolute value for these. Right. Number 4, if f of x equals absolute value of x is compressed vertically by a scale of 1/2 and translated up 14 units. So we know the first one is already vertical. Would translate it up 14 units be vertical or horizontal? Vertical. That's going to be your outside K. What do we think this would start to look like? The 1/2 is going to be your A. Going to start off f of x equals 1/2. And then absolute value of x. Nothing would go on the inside because we don't have any horizontal transformations. And then the translated up 14 plus 14 on the outside. So you have to know where things go, if it's vertical, if it's horizontal, how to put it, how to write it, and all of those things. Questions about this? There are practice problems on the back, but some of them are for a later lesson. Just the first section are questions that you would be able to do right now. You could try the other ones if you so choose. But I want you to try, excuse me, the last two, 12 and 13. Try 12 and 13 on the back. Raise your hand to get it checked, and then time is yours. Let me know if you have questions about those.